Hi everyone. So here we are on the last of these worksheets for chapters 9 and 10 and labs 17 through 20. And the beginning of those laboratory worksheets would be approximately somewhere on page 129. And then I talked to you guys in earlier, remember, watch them in order: 17, then 18. Watch them in order, okay? Because it's 17, 18, then 19, and then 20, okay? Because we do, and as y'all know, your white lab binder is made up of at the front of it, right, is all your lab chapters that have your study guides in the back of it. And you guys already know this. I'm just going over it with you because I want to make sure everybody's always on the same page, okay? And so then you have Appendix A, right? And it has your test tube color, lab, special handling, and clinical usefulness, right? And that's a section that I talked to you about. The very first lab we ever had, the very first lecture we ever had, was the importance of Appendix A. So I hope everybody's looking at that and making sure they're going over that. Then we had our case studies, right? Which is in our next appendix. And you guys have been doing a really good job of filling those out and sending them in. I'm going to have those graded soon and have the grades put up online. And that was your Appendix B, was your case studies. And then Appendix C is all our laboratory worksheets, which you're seeing right now and you used to see when you were in lab, right? And you, again, I said this in the previous video. In the very first video that I did, there's a lot of really good information for you guys at the beginning of that video. So make sure you watch them in order, and they're not real long because they're the lab ones, because we're not in lab, right? But there's a lot that you learn in lab from listening to me, from watching and things like that, from watching videos, and then you get a big part of your learning hands-on in the lab doing things. And we got to do a lot of that when we were in lab, but there was a lot we didn't get to do. And what I'm hoping is we're going to stay on task so no one gets an eye, and you guys study your chapters. And right now, our next lab test is going to be on these chapters 9 and 10 in labs 17 through 20. So make sure, like I said before, read chapters 9 and 10, fill out your study guides and start studying them, okay? Now, you do not have to fill out these worksheets. As a matter of fact, I don't want you to, but they're helpful to go through, okay? So today, we're talking about the GTT, right? That's our analytical test we're talking about. And on our requisition form, one of the things our requisition for is for us to know what that doctor has ordered. So I want you to make sure that you're able to look at this requisition form and see what that doctor ordered and understand that's what he ordered, right? You want to know what your specimen source will be. This is going to be venous, right? Because we're going to be collecting 5 different samples by venipuncture, okay? Okay, and doing the test, but we will pretend you were doing it, right? So the patient information would already be on here, and you would use that to positively ID your patient and make sure you ID them properly. Your specimen source is going to be venous. Your doctor ordered a GTT. What section of the lab does that go to? Chemistry, right? We take those to chemistry. Why was it ordered? Why would they order a GTT? Okay. So let's turn over, okay? Let's go back to our chapters in our lab binder, okay? And remember I told you y'all's could be just a tad bit off from mine, but chapter 10 in our book starts on page 92 in my lab book, and it should be pretty close to you guys. And it starts off with talking about that the most common reason glucose testing is ordered by the physician is to help diagnose diabetes mellitus, right? And diabetes mellitus is that disease in which the pancreas does not produce enough insulin, or the body is unable to use the insulin it does produce, okay? They become almost resistant to that insulin, okay? So the different types of tests for glucose testing, we may do a random blood glucose test. We may do a fasting blood glucose test. We have a 2-hour postprandial test. And that postprandial means 2 hours after you've eaten, right? And then we also have, of course, the glucose tolerance test. The most accurate test for diagnosing diabetes mellitus is the glucose tolerance test, GTT. The patient is instructed to eat regular meals for 3 days prior to the test and then fast for 8 to 12 hours the night before the test. So testing is started first thing in the morning. Fasting blood and urine specimens are drawn as soon as the patient arrives. The glucose levels from the fasting blood specimen must be between 50 and 160 milligrams per deciliter, and the glucose level from the fasting urine specimen must be either trace or negative to continue with the test. If the fasting blood and urine specimens are outside this range, the test should not be continued without the physician being notified. The physician must be the one to determine if it is safe to continue the test. If the fasting blood and urine specimens are within the acceptable range, the glucose solution is administered. Adult patients are given a dose of 75 grams, and it's that little glucola we've seen, right? That's what they get, okay? So make sure you're reading chapters 9 and 10 about this, okay? And filling out your stuff. So this will be a report form for your GTT, and you see that you have right here, we see that we have this right here, right? So they eat normally for 3 days, right? Then they fast for 8 to 12 hours the night before. They come in, they have a fasting specimen of both blood and urine taken, right? And it must fall within a certain range for them to continue with the test. Okay, also remember that if any time during this test the patient vomits after they drink that glucola within 30 minutes of the test, then you need to get with their physician, right? Then you have a half-hour specimen. Then, if everything is good, you time the glucola began and ended, okay? You have a 1 hour, a 2 hour, and a 3 hour, and you put who the test is performed by, and of course this report form will be filled out to match our patient, right? So, remember, okay, so after the glucose solution is administered, blood and urine samples are taken, okay? So I just want to point that out to you, that it's after the glucose solution is administered. Blood and urine samples are then taken at the half hour, at the 1 hour, 2 hour, and 3 hour. Okay? Venous blood samples are preferred for the glucose tolerance test. If, for whatever reason, the phlebotomist feels it would be impossible to get 5 venous samples, he or she may take all the blood samples by fingerstick. That would, of course, be noted. However, remember, if you're going to make the decision to do fingerstick versus venous, it all needs to be done the same way from beginning to end. All venous or all fingerstick, okay? Not one or the other, okay? So then we will record our results, right? Okay, so like I told y'all guys earlier, okay, that GGT is used to be, it's used because it is the best test used to diagnose diabetes mellitus. Okay. Now, a newer test, the hemoglobin A1C test, is often used. However, the GTT is still commonly used today, especially for pregnant women, to test for gestational diabetes. So I'm going to be honest with you, most of the time, even when I was working, which has been a little bit ago, we mostly only did the GTT for gestational diabetes, and we used the hemoglobin A1C for the rest, okay? So you would always want to perform QC or check to see if it had already been done. You collect your fasting sample if you're going to be the one running this test, right? If you're running a test, you always either check to make sure QC has already been performed, or you perform it before that test is run, okay? And then, so pause this. We've already went through this, so you make sure you pause this and you read through this, and make sure you note down there at the bottom, proper documentation. It needs to be documented on the requisition form, the master log or the patient log, and the quality control log. So pause this and make sure you go through it. And make sure you remember that for an adult, the standard dose is 75 grams, and it comes in a pre-packaged solution, as you see right there to the right, and 1 gram per kilogram of body weight for children. And 1 pound is approximately equal to about a half a kilogram, okay? And remember, once they start drinking that glucola beverage, they must consume that entire beverage within 5 minutes. And you also want to contact that doctor if that patient vomits within the first 30 minutes of drinking that cola and starting the collection process. And remember, once it's collected, because you take that fasting first and make sure they fall into a certain range and it's good to move forward, you move forward, they drink the drink within 5 minutes, they don't get sick, and then you start collecting the specimen at the half hour, 2 hour, and 3 hour, okay? So talking about a glucose test. Okay. What did our doctor order? Look at the rec and tell me what they ordered. It's just a random glucose, right? And we talked about that. That's in chapter 10, that random blood glucose test, fasting blood glucose test, 2-hour postprandial, and the glucose tolerance test, and the hemoglobin A1C test are all tests we use to diagnose, monitor, and treat our diabetic patients, right? This one is just a random glucose, okay? So is your patient fasting? Maybe, maybe not, probably not, okay? And that's why you always want to ask them, okay? If you do talk to your patient and you find out that they are fasting, you make sure that you change that. Make sure that you note on it that that patient actually was fasting before you did this glucose. So what section of the lab does it go to? Chemistry, right? Why was it ordered? It was ordered to either diagnose, monitor, or treat a person for diabetes mellitus, right? So pick the tube, possible tubes. If we were in lab, you know, always, as we were moving on, I would get you guys to pick the tube and kind of hide it. We would see if you would pick the right tube. So what would have been the best tube for this random glucose? A gray top tube, right? A gray top tube would have been the best tube for just this random glucose, or for fasting blood sugar, or for the GTT, because it has a preservative in it that preserves that glucose. And remember, we use one of these labels, the one with the barcode, to go on our specimen, and one of those goes on to our patient log, right, that's kept in the lab. So, and you'll see here, if you were to collect blood by skin puncture, and you were actually doing the glucose test yourself, before any test is run, QC must be checked or run. Okay, so if we run that glucose result, QC, you would do your QC. If it came in and it was acceptable, then you would do the patient's test and record the patient's test result on the report form. And if you'll see down there where that circle is, that's where you would write your patient's results down there. Now, your requisition form would already have all your patient's information on it. Okay, you would write in the time that you collected your glucose. You would write in the time that you performed your glucose. You would check your QC, make sure it had been done. Okay, then you would perform your glucose test. You would write down your results. You would compare them to the reference ranges that are provided on this report form to make sure that they were in normal range. And then you would put your initials as the test performed by. Okay, you would also need to fill out the test results in the patient log. This logbook is kept in the lab. Each and every test run in the hospital and its results are recorded in that patient's log. And it's either a log they keep in there or it's something that's inside the computer. So remember, quality control is always ran first before the patient's test. Now, there are 3 levels of control: the low control, the normal control, and the high control. But according to CLIA, how many levels of control should be run? 2, right? And we want to run low controls because we want to make sure that whatever instrumentation we're using is able to catch a really low glucose level. Okay, we run normals because we want to make sure our instrumentation can properly catch normal glucoses And we run highs for the same reason. We want to make sure that that instrument can catch something if we have a patient that's running a really high glucose. But CLIA, which is our law that states we only have to run 2 levels of control. How often do we have to do that? Every 8 hours or each day of patient testing. And in other words, if you work in a physician's office and y'all work an 8-hour shift and no glucoses are done that day at all on any patients, then you do not have to run controls that day. But if you work in a doctor's office and you know that you do glucose on somebody at least once every single day, then the best thing to do is when you get in that morning, go ahead and run your glucose controls so that when your patients come in, you'll be good to go and ready to go. That helps you with your turnaround time. So if one of the controls falls out of range, is it okay to go ahead and do the patient's test? No, not at all. You must not use the instrument to perform the patient's test, or you must do some type of troubleshooting, such as opening up new test strips, changing the batteries out of your instrument, cleaning your instrument, calibrating your instrument. Was it a human error? You need to solve this problem. Make sure that you figured out what caused that control not to be out, rerun those controls and have them come in range before you use that instrument. If you cannot get that instrument to perform properly and get your controls to come in range, then you do not use it and you switch to a new instrument that can have their controls come in range. And make sure you document every bit of this. Why? Because if your controls aren't coming in right, then your patient's results are not coming in right and they would not be accurate, and we never report out inaccurate lab results. So what do? Remember, we take corrective action like I talked about, okay? You find out what went wrong. You try repeating the GTT test because sometimes it's human error. We made a mistake. We repeat them first to see if we can get them to fall in range. If not, here are some of the things that we may do. Remember, somebody might not have put the cap back on our test strips. If you leave them out at room temperature, that could affect their abilities to work properly. If they didn't put the controls back into the refrigerator, or if they contaminated the controls not be working. There's lots of things that you can do to troubleshoot and take corrective action to get your problem solved. You always want to be a problem solver. How often should you calibrate the glucose instrument? Monthly, or according to the package insert or directions that comes with the instrument. Make sure you're always familiar with all your instruments, all your test kits. Make sure you thoroughly read the package insert and directions that come with any kit or instrument before you start using it. So if we were in lab, we would run some controls, abnormal high and abnormal low. We would enter the QC results. We would enter them on the QC log, and we would do what they call a Levi-Jennings chart. Sometimes the QC results are graphed on a chart called the Levi-Jennings chart. The Levi-Jennings chart is where we enter each day and we show what our QC results were. Then what you do, and a lot of you have seen a graph before, you put a little dot by the date it was done and what the results was, and then the next date and what the results done, and then you take a ruler and you connect those dots. You'll see an example here. The previous was our low, this is our high. Okay? And the reason we want to chart these things on a graph is because we may not have one that's going out, okay? Your results may be coming in, but someone should be reviewing that Levi-Jennings chart on a daily basis because it can tell us. And I always use the example, you know how sometimes you may go out to your car and you go to crank it and it's a little hard to crank? In the back of your mind, you kind of know something's going wrong with your car, right? But it cranks up and you go on about your merry way. If you don't take the time to find out, hey, is my battery going out? This is your car telling you, hey, your battery's not working as good as it does. Now, it's still cranking your car right now, but something's going to happen. That's kind of what the Levi-Jennings chart is for, because if someone is reviewing those charts on a daily basis, they can see trends where all of a sudden, little by little, these results are starting to go out. It may give us telltale signs that something's going wrong with the strips, the reagent, the batteries, and the machine, so that we can get on top of solving that problem before those controls are going out. Because if the controls are steadily going down and showing a lower and lower result, our patients may be doing the same. So this is something that's very helpful for us to catch problems before they're actual problems. Because one day you'll walk out there and go to crank your car and it won't crank at all. We want to avoid that. So make sure that you're reading over each one of these slides. You can pause it, you can rewind it, and make sure you're reading chapters 9 and 10, filling out your study guides and studying them. So capillary puncture to make blood smears from the finger. We went over this stuff before. I want you guys to just pause this, look at this, kind of go over it, kind of don't fill it out, but kind of go through it in your mind as to what you would do. Answer each one of these questions. Refer to your Appendix A to make sure that the answers you're answering is correct. What specimen source you would have. It's going to be capillary, right? Because it's coming from a finger. What tubes would you draw? What slides would you make? Where do you deliver this to? Does this go to hematology? Okay, so if we would have done this, there's a picture right there in your top right hand corner of a glucose machine that we would have performed in our lab, and we may very well get a chance to do that, and I'll put up a video about Levi Jennings and QC, and then this is an example of 2 blood smears that would have had the appropriate label on them with the patient's full name, the date that you did it, and your initials, and you want to make sure that's always what you put on there. And remember, again, I hate to harp on this, but we learn by going over and over stuff. So if you guys are reading, filling out your study guides, and then taking the time to go over and over and over and reading over your study guides, you will learn this stuff and you will be effective when you take your test. And remember, every day before we left lab, we would always make sure we threw our waste away properly. We cleaned our area. We would always make sure we would take that lab coat and put it in a plastic bag because we didn't want to spread those germs. And lastly, we would remove our gloves. Guys, make sure you're watching these videos in order, especially that first one. It has a lot of really good information right there in the beginning. Watch your emails, and please, please, please study this stuff, okay? The test will be coming before you know it, and I don't want you guys to get behind or bogged down. Hope everybody's being safe out there, and have a great day, okay? I'll see you guys soon.